Hey guys, STAT1800. Follow up on videos that we've put up before. Our focus right now is on confidence intervals, and we're kind of keeping it simple here, and we're just focusing on confidence intervals for mu. So what you know so far is they kind of come in two shapes and sizes. First of all, we run into these where the population standard deviation is known, in which case we construct what's called a z interval, and these things are modeled with the z distribution, which of course is a normal distribution, mean 0, standard deviation 1. The other type of problem that we run into is where sigma is not known, and we make those calculations from what's called a t interval. Now, this calculations use what's called the t distribution, and instead of these things being defined by their mean and their standard deviation, they're defined by their degrees of freedom. And guys, remember, degrees of freedom is really easy to find. It's just the sample size minus 1. Now, the main purpose of this video is to work some problems that are on my stat lab. But first of all, I want to point out some a difference in notation on some of the problems one of the problems you'll run into versus the way I teach it. Now, we have seen a problem previously, so something like this. Find the critical value for an 80% confidence interval. So let's confidence interval t star. So let's make it clear we're looking for the a t interval. Okay. So find the critical value t critical for an 80% confidence interval when our sample size is 18. Now, the way I taught this to you guys is you want to examine your distribution. Just draw some sort of normal distribution. Doesn't have to be pretty. And we know that this t distribution, just like the z distribution, is centered at 0, but the variation changes based on the sample size and degrees of freedom. Nevertheless, at the end of the day, what we want is we want a negative t critical and a positive t critical, because it's an 80% confidence that contains, let me get this where you guys can see it. Whoa, it's kind of large, isn't it? All right, so between the two values. Now, typically, it's kind of a given that when you say find the critical value, you notice that you've got two of them. You've got a negative and a positive. But when you find the critical value, it's only wanting the positive value. Okay? So to do that, we would go to StatCrunch. Oh, shoot. You guys see what I'm looking at, right? I was looking at college football. And it just so happens something else. It probably won't apply much for my students in future semesters. But there's a lot of talk right now about NFL players taking the knee during the national anthem, and there's people that have a lot of strong feelings both ways about that. So I was also reading that. By the way, I'm not going to tell you how I feel. I really think it's kind of tacky. I'm just talking while I get to StatCrunch. I think it's kind of tacky when professors promote his or her political agendas. All right, so as we've done before, I go to stat and I go to calculator and I get down to t, because we're dealing with the t distribution. I need to select between. My degrees of freedom are 17 since my sample size is 18, and I need the area below or between to be 0.80. So guys, the correct answer here would, again, just looking at the positive, it would be 1.3334 would be the positive critical value for an 80% confidence interval. Now let's have some fun. This is where it kind of gets wacky. That's not the way that my stat lab will ask you to work that problem. What they will do is they'll say this. For the same problem we just did, this is the way, same problem, but the My Stat Lab presentation of that problem, the way it'll be posed to you. They will say, find the upper tail critical value T alpha over 2 when 1 minus alpha equals 0.80 and N equals 18. Now, that could be confusing for first year or even 1,000 level statistics students. What you got to do is you got to focus on this number right here. This is the confidence interval percentage. So that 0.80 tells me that just like I did in the previous problem, that's the value that goes in the center. And of course the sample size is 18, and that's given right there. This T alpha over 2, let me explain to you. I don't want to confuse you, but I want you to understand the connection. If we look at 1 minus alpha equal 0.80, then with some simple algebra, I can solve for alpha. So I can take this negative alpha across and bring it over here and make it a positive alpha. And I can bring the 0.80, it's positive, bring it over, it becomes a negative 1 minus 0.80, which is 0.20. So this says that alpha is 0.20. Now if I bring this down, I have T alpha over 2, so alpha is 0.20 over 2, which makes it T of 0.10. That's the upper tail. That's the area that goes in the upper tail. So going back to the value, the drawing that I create, minus T critical, positive T critical, the way I start is I start in the center. It doesn't. It starts with the upper tail and says that that upper tail must have 0.10 area. Well guys, because of symmetry, if the upper area is 0.10, then the bottom tail has to have area 0.10. And because this entire area must be 1, this part here must be 1 minus 0.10 minus 0.10, which gives you 0.80. So instead of teaching it like me, which I think is the easy way, to start with the area in the center, which corresponds directly with the confidence interval level, they start with the upper tail value and kind of work backwards to get this value. Guys, the easiest way to do it. Now, I think if you want to, well, you really don't have any input because I can't hear you. We can work a problem. So, well, I don't know. Let's find the upper tail critical value. T over alpha divided by 2 when 1 minus alpha equals 0.92 and equal 42. Now that's a bunch of gobbledygook maybe for some of you, but what's that tell me? I want a 92% confidence interval when my degrees of freedom is 41. So guys, I'm going to go to StatCrunch. My degrees of freedom is 41. I want my area in the center to be 0.92. Look at the positive only. So my positive T critical is 1.7952. Okay. I hope that's not confusing. I mean, I'm not trying to make it that way. It's just a difference in. I like the way that they do this. I mean, this to me this notation is going to be very, very helpful when we get into hypothesis testing. But I think it's a little bit confusing with confidence intervals. All right, gang. I told you earlier the purpose is to work some problems, and if you go to homework, you're going to see that I've uploaded a demo for confidence intervals, not for credit. All right. So had a little technical glitch there. It's gonna seem clumsy for a second, but actually I went to homework, and you can see that we're talking about this demo confidence interval means not for credit, but I'm gonna need to go through or with it through this angle. But you guys go ahead the way I showed and follow along with me. So I'm gonna go down here for something that instructors have the option of doing and doing preview. Now I want to shut down these stat crunches. No, I didn't. I did not want to do that. I actually want to bring up StatCrunch. So let me pull that up real quickly. I want to close this one. All right. So go to Course Tools. Guys, this has been the hardest video for me to put up. It just seems like everything that I've tried to do has gone wrong. Okay, so a bottled water distributor wants to estimate the amount of water contained in 1-gallon bottles purchased from a nationally known water bottling company. The water bottling company specifications state the standard deviation is 0.02. So guys, that tells me that the standard deviation for the population, sigma equal 0.02, is implied. Now, once I start this statement that I've highlighted, it starts talking about the sample. Any standard deviation that would be given, and there's none in this case, but any standard deviation that would be given in that sentence, in that reference, would be a sample standard deviation. But this statement right back here is talking about the standard deviation for the company's specifications, which implies the population of water bottles. Now, as I read further, I can see that we have a random sample of 50 bottles. It looks like the sample mean is 0.993. And I'm just writing all this stuff down on a sheet of paper. Complete parts A through D. Well, guys, all this put together, I know that I am going to construct a Z interval because of this statement right there, because I'm given a statement about the variation, the standard deviation for all of the bottling company specifications. Okay, so first of all, construct a 95% confidence interval. So guys, I'm going to do that. So I'm going to go to Stat. I go to Z-Stat because the population standard deviation is known. And then I go with summary. All right, so the sample mean is 0.993. The population standard deviation is 0.02. And the sample size is 50. I need a confidence level of 0.95. Is that right? Yes. So I compute. The lower limit, let's see, it wants us to go around to 5 decimal places. That's interesting. So 5 places would be 0.98746 and 0.99854. So the left bound 0.98746, and the right bound is 0.99854. All right, on the basis of the results, do you think the distributor has a right to complain? Well, the claim is 1 in our entire the claim is 0.993, and 993 is contained in our interval. So I say no, they don't have a right to complain because 1 gallon lies within the interval. What's going on here? Oh, no, guys, I was right. There's supposed to be 1 gallon. Well, certainly 0.993 is going to lie in there because it's the sample mean. Does 1 gallon lie in there? So, yes, they have a complaint because the 1 gallon bottle containing lies outside the 95% confidence interval. I would tell you it's the first mistake I've ever made, but I think I'm going to have a hard time selling you on that one right now. Must you assume that the population amount of water bottle is normally distributed? Well, the answer is no, because anytime we get a sample 25 to 30 or higher, the central limit theorem says that the distribution of sample means will be normally distributed. So must you assume? No, because the central limit theorem says it's X bar is normally distributed when n is large. So in this case, it's large. So again, what's large? Anything above 25. Construct a 90% confidence interval, so that's going to be simple to do. Z-stat, 1 sample with data. Z-stat, 1 sample with summary. So sample mean is 0.993. Standard deviation 0.02. And sample size is 50. And we want a 0.90 confidence interval. So I'm going to assume 5 places, so 0.98835 and 0.99765. So 0.98835 and 0.99765. If I didn't make a typo, we're going to get it right. How does this change your answer from part B? Well, 1 gallon water containing exactly 1 still lies outside the 90%, so the distributor still has a right to complain. All right, a survey of nonprofit organizations showed that the online fundraising has increased in the past year. I find that hard to believe. Based on a random sample of 50 nonprofits, the mean one-time gift donation in the past year was $33. So that tells me that X bar is 33, and the standard deviation would be SX in this case because it's within the context of information on the random sample. So this standard deviation is not sigma, the standard deviation is S. So guys, this tells me that we're going to use a t-distribution, and we want a 90%. We'll start writing this stuff down so when I get over there, I can make it happen. So guys, go to t-stat, 1 sample with summary. So the sample mean was 33. The sample standard deviation was 9. And the sample size was 50. Is that right? Yeah. And we want a confidence interval, but I want 0.90. Now let's go over and see what, probably two places, yeah. So 30.87 to 35.13. So 30.87 and 35.13. All right, interpret the interval. So the quality improvement team can be 90% confident that the new population mean is the midpoint. No, it's not the midpoint. The midpoint is the sample mean. The quality improvement team can be 90% confident that the new population mean turnaround is contained in the confidence interval. Seems reasonable. Can be completely sure, can be completely sure. Guys, you can't be completely sure on any confidence interval, so B is clearly the right answer. All right, question 3. The table below contains the amount that a sample of 9 customers spent on lunch at a fast food restaurant. So we want to construct a 99% confidence interval. So guys, we know we're going to use a t-interval because the population standard deviation isn't given anywhere. So for this problem, we want a 99% confidence interval. And these are the easiest kinds because you can open this up in StatCrunch. Now, guys, when you get here, make sure that you check the first row and make sure that the variable name isn't there because sometimes it'll do that to you. But in this case, we have the 9 measurements, the 9 amounts paid for lunch as we need them. So guys, we're going to t-stat, one sample. Because in this case, we don't have the summary, we have the data. So I want to construct for amount, and I want a 99% confidence interval. There's other things you can do. You can do histograms and dot plots, and there's a Shapiro-Wilks normality test. You know, a lot of cool stuff, but right now we're keeping it simple, so I want to compute. Now let me go back and make sure I need to 2 decimal places. So which one do I want? Amount, right? Yeah. So I want to close this one down just to make sure I don't make any mistakes. So 5.07 to 9.00. All right, interpret the interval. So there's a 0.99. We have 99% confidence that the mean amount of dollars spent for lunch. Okay, the mean amount of dollars spent for restaurants, that's not 99%, no. So guys, if you read that very carefully, that's the only one that, now the difference in, well, the difference in it in the first one was, it was the mean amount spent at the fast food restaurant. They're trying to generalize to all fast food restaurants, so that was the little caveat they threw at you there. All right, I'm going to shut this down, go into a new problem. So is there a difference in the yields of different types of investments? It looks like we're going to have 1-year CDs and 5-year CDs. So click the icon. So we want a 95% for 1 year. All right, so let's keep it, make it easy on ourselves and open this up in StatCrunch. So for these numbers, I want a 95%. So guess the population standard deviation is not given, and I have data, not summary. So I want 1 year. I want 0.95. Let's go for it. So it wants me to let's see, 2 decimal places. So 0.63, 1.11. Constructing 95% for the 5-year. So 4.13, 4.53. Compare the results. Now guys, when I look at this, I look at the 2 results. I see 0.63 up to 1.11 for A, and I see 4.13 up to 4.53 for B. The thing I see is those don't overlap. Now, if this interval, I don't know why, but iTunes is going crazy down here. If this interval, for example, started with a number less than 1.11, but was higher than 0.63, in other words, contained in this interval, then we would have an overlap in the intervals. But we don't have that. So that tells me that this interval here is significantly higher, statistically higher than this interval right here. Now, again, if these overlapped, it wouldn't be the case. So let me get out of that. There's a nice picture. That is taken in Isla Mujeres, Mexico, with the fam. All right, so I wish I was at Isla Mujeres. I just finished a day of diving there, and I was in a really good mood, having a margarita and listening to some guy sing, which he was actually really good. So if I had a interval from 1 to 5, I know that this interval is completely below that interval. This interval is completely above this interval. This interval has an overlap. Okay, and it's easy if we go from -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12%. Pretend there's a 12 out there. This one goes from 1 to 5. This is from -1 to 0. No overlap. This one is from 7, so this is 4, 5. So this one is from 7 all the way up to 12. No overlap. But this one is from 3 to 9. Somewhere there. You can see there's overlap. So when there's overlap in the interval, that says that there's no statistical difference. But anytime these intervals don't overlap with the base interval, in this case 1 to 5, that means that there is statistical difference. Wow, that's making me miss Mexico. So one can be 95% confident. Guys, we can't be 95% confident about the comparison. We'll get into that when we get into pooled and unpooled 2-sample t-test. But right now, the 95% applies only to this interval, and this 95% applies only to that interval. The 95% doesn't come down to the comparison. So we can make a much stronger statement here that the mean yield for 5-year is greater than the mean yield for 1 year. We don't have to okay. Well, how about that? One can be 95% the mean yield of 1 year is the same. So guys, I'm confused here. Let me think about this. Okay, I see. We're using the same 95% in both cases, aren't we? So we actually can, and the mean yield of a 1 year is less than that. Obviously it's less because this interval is below Yeah, I was reading it backwards. So guys, the correct answer would be B there. Okay. Well, guys, when you're working your assignment, go with that. One can be 95% confident that the that's awful tricky. I tell you, I don't agree with that. I have to tell you. Statistically speaking, I'm not sure the confidence level stays stable over the comparison of the two intervals. Well, I'll tell you what. Let me hash that one out. For now, just go ahead and say that you can be confident that the comparison of the two intervals. Yeah, I'm not buying that one. I think I'm gonna have to contact Gould on that one and talk to him about it. I'll tell you what. Since I messed that up, let's do a similar. And if you're fine with that, you can end the video. I promise you, there's not going to be a sneaky quiz from here on out. But if you want to see it work correctly, hang around and let's do that. So we've still got. I'm sure it generates new data. Yes. So we went for the first one. So T-stat, one sample with data. Then we went to 1 year, and we want a 95%. So 0.62, 1.12. And what did I do? 0.62, 1.12. Oh, 90%. Guys, I tell you what, man, I am struggling. I will tell you what the issue is. I'm not losing my mind. I have a meeting in about 9 minutes, and I'm trying to rush through this, and it's just not working. So 0.66, 1.08. All right, 90% for the second one, for the 5 year. So 4.17, 4.49. So again, we have both intervals. Second interval is higher. So we have 90% consistent. Both intervals are 90%. So one could be 90% that the 1 year is less than. All right, that's going to be right. All right, guys. Sorry for the confusion. I'm going to end this video so I make my meeting on time. So again, sorry if I confused you any way whatsoever. If you need more clarification, let me know. Come see me in my office. We can do Google Hangout. You can call me. You can email me. So have a good one.